Good afternoon, everyone. My name is Neel Kamal, and I am going to give you a product walkthrough. Aviatrix software-defined cloud network. We have two components. We have the controller, and we have the gateways. Gateways are basically routers. These are the cloud router or software-defined cloud routers. These routers sit in your VPCs, in your VNet, in your Google Cloud projects, and using the central controller or AVX controller, which is where the brain says, all of these use cases are able to build. Now, the journey in the cloud is not a point-in-time journey. It's over a period journey. In this time of 5 years, let's say, people will have different problems. It might start with connectivity to on-prem. It can go into egress, like you saw. It can go into user access. It can go into multi-cloud. It can go into remote offices, all of that. Many people don't have all of these problems at the same time. They start with one, and they go through the journey. Aviatrix philosophy, as you would see in the product, is to help you throughout that journey in the build process, as well as from an operations process. We call it the day one and day two. Day one is all about building, and day two is all about operationalizing. So I'm going to start my demo with the controller, which is where you will see many, many functionalities of Aviatrix controller. And then I am going to take you through use cases and build or show you how you build these use cases. Okay. Now, just a reminder why people choose Aviatrix, and you heard some of this before. It's because of the simplicity, extremely simple. It empowers a cloud engineers to behave as a network engineer and a smart one. It's automation. Automation is for governance as well as for achieving your end result faster. A quick example could be, anyway, cloud engineers have a Terraform, which is being used to create the VPC. Wouldn't you want to add 2 more lines to it to take care of networking and 2 more lines to it to take care of security, rather than 1 more tool for connectivity, another tool for security, another tool for user VPN? That's the idea. People refer to it as network as code as well. Built-in security. Rather than security coming in later, being bolted on and redistributing, redesigning your network architecture, wouldn't you want a system which can be building your network and then having security built in? High performance. This is all about taking, currently people are at the 5-10% of the workload going into the cloud. But there will come a time when the entire data center will be in the cloud, and therefore high performance is only a given. It's going to come, it's going to be needed. And then finally, multi-cloud. A lot of customers, their journey starts with one cloud, but certainly there is need for being able to handle multiple clouds.
So just a comment while Neel is bringing up the demo. For the folks that have used a virtualized router, maybe you can comment on do you see a difference between what we are saying are the software-defined features versus a virtualized router? Any comment from the delegates?
So I was just trying to get my head around the whole idea of the difference between the two.
Yeah.
So just to clarify, you are running the software, the gateway, inside of a VM on a public cloud, right?
It's an AMI gateway. Yeah, that's right. The cloud
so all
router.
traffic flows through that one instance?
It's inline, that's correct.
It's inline, it's not distributed across multiple, it's not distributed routing like some of the other products do.
Sherry, do you want to comment on
that? So it is fully distributed, centrally managed, fully distributed. For example, like in this case we mentioned about, right? This is what I didn't draw is because this is an architectural diagram, so it doesn't have the product. There is a controller here, and that itself is a AMI in AWS you launch, or could be in Azure, or could be hosted by Aviatrix. And from the controller, you launch these gateways. Okay? And the gateways, your question is, they are in the VPCs. Their job is the brain is in the controller. The gateway's job is forwarding traffic to on-prem, or terminate user traffic, or the traffic to internet, or traffic to another cloud.
Yeah, but they're not distributed across multiple hosts inside of that VPC because you don't have access to it.
No, we're not agent-based.
Exactly.
We are a instance. So from the agent point of view, it's completely transparent. They use so we think VPC, EC2 to EC2 communication is through AWS or Azure. infrastructure. We are at the boundary of connecting VPC to on-prem, connecting VPC.
Yeah.
Does that make sense?
Yeah, that,
So,
that makes sense.
Can I just quickly ask that, these controllers, both are AMIs, of course. First of all, are they resilient, HA?
Yes.
And if they are, then are they active?
So to answer to your question, first, they're HA'd. We leverage, so we're a cloud native networking company, right? So we use a lot of the cloud providers' native services. So for our controller HA, we use AWS auto scaling to run the controllers. And they're not active. There's a single one. There's a database behind it. In the controller. The reason we haven't seen, in fact, we run our controller in T2 large. T2X large can run 500 to 1,000 gateways. The reason, the secret is it's not in the data plane. Its job is monitoring and provisioning. And even if this thing dies, your network doesn't go down.
So the same question I was going to ask for the gateway as well.
Yeah.
So you've already answered that. But what if, say, for example, the gateway, like you said, active. It's again in the same way.
HA-based.
HA-based, but
it can run active.
So the reason why I'm asking all these questions, controller, yes, you can live without the management or monitoring for a while. May not be able to change configuration or something while the other one comes online. But the gateway services, for example, now we've established that one is up all the time. It's not fully resilient. So if one fails, the other one needs to come online.
Yeah.
How long does it take? What happens in between?
So the transit and the spoke, they can be active. In fact, for example, if a spoke gateway die, if the entire thing has to swap to second one, we're dead, right? So this link go down, and the stand-up one will build this connection. It's in the seconds.
Right. So
Switch over,
Small
it takes
number of
1 or 2 seconds. It's the detection time.
Right.
And detection time is configurable. We have fast, medium, and slow. It depends on your tolerance of the what do you call that, the flopping.
Right.
So yeah, you can be as low as in the seconds and as high as in the low minute, 45 seconds or something like that. The actual switchover is very simple because all we are doing is switching the route pointers to this one or to the other one.
Right. That answers my question.
Yeah.
That answers it.
Okay.
Thank you.
Okay.
And if you're using the user VPN component, does the user then retry and connect to the failed node, or would that user have to reestablish their whole session?
They don't actually, because they run behind the ELB. Like actually, Netflix is our first customer for the VPN. They run 20 gateways. It's like a fleet of gateways, and they run load balancer in front of it. And load balancer itself, AWS load balancer, will do heartbeat to these gateways. So when the gateway died or is dead, it would automatically detach. So user will not even notice the difference. And of course, the OpenVPN client, which is what we use based on will retry. Most of the time, you do not even notice when the gateway died. It would just select the other gateway. Does that make sense? Yeah.
And on your last slide, you mentioned about multi-cloud also on premises. So what's the interaction between the cloud, which is its provider, public, it's AWS or what else, with on-premises cloud, that's called cloud. So for example, VMware by connecting in IPsec or which is the interaction?
Yes.
And the connection, is it the VPN?
Yeah. So for these three, can you go to onboarding, Neel? So these are the clouds we support fully native, meaning that we run their APIs, we behave like we know everything, right? For the other clouds like VMware, Oracle, and we behave like we can interact with them. We can build IPsec VPN with them. Yes.
Okay.
Yeah.
So NSX
To Aviatrix.
Aviatrix.
Yes, that's right. Yeah.
Okay, that was the question.
It was the same question about
Yes.
Great. Go for it.
Is that configuration of NSX automated from your controller?
Right now, no, it's
Okay.
not. But we can interact with them. In fact, in our last field day, we had a demo of interacting with NSX. Yeah.
That's right.
Yeah.
More questions?
Yeah, is full Oracle support coming?
Yeah.
Full or
So we just had customers start to request
Two.
Oracle. So in the next release, we'll be at least talk with Oracle, yeah. But to be Oracle native, we're not there yet. Do you have real?
Coming, yes, but not right away.
And also,
in
do
over
you
period of
have?
time.
Is this curiosity question, or do you have real demand for that?
Anticipated demand.
Anticipate demand. Okay,
All right.
thank you.
More questions? Okay.
What would you be a requirement to integrate with other cloud platforms like the on-premises like NSX and ACI? You want them to have APIs that are easy for you to consume and work against? Is that basically your requirement for integrating those in future releases?
Yes, it's because we already have a layer, and we have an architectural diagram later that shows where we are and how do we interact with it. Yeah, it's the API exposure basically.
Technically that,
Yeah,
and
but-
otherwise lots of people asking for it would make it
Yes.
happen.
Yeah.
All right. Okay, let's look at a demo. So like I said, Aviatrix controller and Aviatrix gateway. Think of gateways as cloud routers, software-defined cloud routers, and there is a flavor for every type. There's the AWS type, there is the Azure type, there's the Google type, soon to become Oracle type, and what was the other one? VMware type, and the HP type, and the IBM type, all of them coming eventually. Aviatrix controller is where the brains are. So I'm going to show you some of the brain part of it. The cool part of it is the entire cloud networking, not just AWS, is plotted on a world map. You can also see it on a logical map. You can try and redesign it. You can say, I want to see it in a transit way. You're going to move these things and plot it the way you want. You can save it. As you go through it, realize that none of these things are available in the cloud. You might be familiar with tools like this in a data center, but try to do this across multiple cloud together with data center, simply not there. Another cool thing, you hover your mouse over, it tells you transit US West 2 is connected to app dev 2 on a real-time latency of 79.592 millisecond. Something you would want your operations guy to always know, but very hard to capture. You can also have bandwidth and many other metric map. You can select the gateways. Again, gateways are cloud router. You can choose one or many, and you can then plot against these metrics. You can look at data, total data sent, cumulative performances of different kind, averages. There is memory, there is CPU, IO blocks, various other metrics available here. Now, these are the controller things. These are not about the particular use cases. Across all of the use cases, you will have these benefits. That was the dashboard. Let me show you something very cool on the troubleshooting side. Flight path, a very cool tool. What it does, all of you probably have had situation where a developer requested, I have an instance in US West 1, I have another instance in this US East 2, and they're not talking to each other. In the construct of the cloud, the problem is not complicated because it could be either the route table problem or the security policy problem or one of the NACLs are misconfigured. But this happens all day long because there are too many different constructs and it is different from data center. Troubleshooting this to an expert might take 30 seconds. To somebody who is new, because there are lots of people who are new in cloud network, it might take an hour, 2 hours, depending upon how fast they get. With Aviatrix, there are tools built in to do those kind of troubleshooting within seconds. You can select an instance on the left, select an instance on the right, launch flight path, and it will bring all the information from all of the API calls together in a left and right pane. You can scroll through it, and very easily you can visualize where the problem is. Diagnostics. Let me show you a simple thing. There are many things here. I'll cherry pick a few things, and feel free to ask questions. Many of you probably have instances where somebody says, well, I am in this particular specific machine, and my app is not able to access, let's say, Salesforce.com, because I have an API access to Salesforce, which my app requires. And that instance lives in app prod 2. You just go to the central controller, the one place, just like AWS has a central console. Think of this as networking central console, and you do traceroute. Now it is you're not required to find that instance, find which VPC it is, log into that instance, and do all of those same things. You can do it from the ease of this one central place. And on, there are many, many tools like this. Packet capture, something many people are familiar with. How do you get that in the cloud? You just choose your gateway, interface, hostname, port, start, capture it, stop, download, put it in your PCAP tool or the tool of your choice, analyze it there. So there are many things built like that. And all of that is available as a part of the central controller or Aviatrix controller. Go for it.
Yeah, a lot of times when you try to do a packet capture on a cloud, it throws up all kinds of red flags. Because you guys are partnered with those cloud vendors, this is okay?
Plus, we are in the path.
Okay.
The thing about is that ultimately there is a router that Amazon is running on also. It's just that you don't have any access to it. If you're a network engineer and they give you their, I'm guessing, Cisco, Juniper, whichever router, sure, you can run all of these, but you can also run the rest of other customers. So for segregation reasons, you have no visibility, no control. Obviously, makes sense. But by putting an infrastructure of this type, you are for the first time able to get visibility. You are able for the first time get some controls. And most importantly, you are empowering a general purpose cloud engineers to be able to do networking. Because let's face the reality, that's what is happening. Take a team of 10 cloud engineers. How many network engineers do you think there will be in that? Very, very few, if at all any. And that's other thing that is happening to all industry. Do you think people are hiring storage engineers to manage S3? Not really. A general purpose cloud engineers is empowered to do all of these things using Terraform, CloudFormation, and things like that. You will see a lot of it here. Good question. Yeah.
Is the I'm hoping I didn't miss this earlier, but is the controller, is it an AMI? Is it available in the
Yes, it is.
Amazon web? Okay.
Correct.
Marketplace.
In the
Marketplace.
marketplace.
As well as in Azure.
Okay, so all of these things that you're doing here for troubleshooting, I'm guessing I could also do that programmatically? Like if I notice that I have a connection to that app down, I could have it run through these steps in a scripted way?
That too, but the actual practice in production is ultimately Aviatrix Cloud Router, called the gateway, in that VPC, is the one which is producing the information, and that's the unique part of it. Where you analyze that information, what you do with that information would depend upon your choice of the tool. There will be people who would want all of the logs into Splunk, analyze it in Splunk. They wouldn't like our UI. We will do that. We have built this thing called logging.
I think he's asking, you can use the API to access these tools.
Correct.
Everything
is REST API.
Is REST API. Everything
Correct.
you see.
If you want to build your own, but a lot of people also use a central tool to do some of these things, and you can export the data there and do that too. But yes, REST API everywhere. More questions?
I have.
Yes, please.
So first of all, it must be my misunderstanding or something, but I want to just clarify that when you create VPCs in your automated fashion, does it also create other networking constructs like the subnets, security groups, NACLs, if you want? So does it do all of that kind of stuff?
Yes,
Yes.
actually we have it under this
Useful
tools, you can create VPC. So in AWS, there is a wizard to create a one public subnet VPC or one public, one private. What we do is we can create a VPC of your account, you give a name, a Cedar block, you select the region, and we will create a public subnet and private subnet in each AZ. And we'll create the IGW, we'll create the public route table, private route table. It's completely fully loaded and ready to go.
Right. And when it's creating those, does it also then create references or output the references to them? Because what I would normally like to do is that when I deploy a VPC, with all those subnets and whatever I need to create with them, then I output that into, basically objects so that I can then refer to them from my other CloudFormation templates.
Yes.
And deploy other things in specific subnets.
Yes, there is an object. Once this is created, there is an object ID you can use as reference
To recreate.
to recreate. Yeah.
Yes.
Okay, because that's...
You're talking about template.
Yes.
Yes. Yeah.
So obviously I would like to use those
Absolutely.
in my data because
That is available.
if there is a layered approach
Yeah.
where I create a VPC and then I create other things but
Yes.
reference the networking constructs
Absolutely.
for that VPC,
Yes.
then
In fact, you don't even need to templatize it. There is an object, Terraform. You just refer that as a resource.
exactly
Yeah.
that's
Yeah.
what I mean. That
That's right.
I typically use CloudFormation, but
Yeah.
Yeah,
same
either.
concept of
That's
Same
right.
difference.
But
Yeah.
it's
That's
basic.
right.
Yeah.
So that's pretty important from my point of view.
Correct.
To be able to do that.
Okay.
Yes. You will see that across the board in other features also. We templatize everywhere. We create tags. If no other question, I'll go through the next part of it. There was a question about CIDR block management. Everybody has a spreadsheet. Again, the central controller gives you a way, and you're seeing it here under Useful Tools, VPC Tracker. You're able to see everybody's CIDR block. Now this is your much smarter, intelligent, and communicating spreadsheet in a way. You can take one of these VPC's ID and try to put it here and test it. It is going to tell you that it overlaps with it. Okay, I'm ready to show you use cases because this is so far about our controller. These are the things that you will have all day long. But ultimately, you have this so you can build a use case. And you heard from Sherry, there are 6 use cases. Let me show all of those use cases to you. Right on the top, you have these listed. The first one is Next-Gen Transit Network. So you click on it. It is as simple as a wizard. It's going to give you step-by-step instructions, and you follow that instruction, and you will have your transit built. A lot of our customers are able to build this in several minutes. Step 1, launch the VPC, Transit VPC. Step 2, Transit VPC gateway. Step 2, make it HA. Step 3, connect it to VGW. Spoke 4, launch a spoke gateway. Step 5, make it HA. Step 6, connect it to the transit. That's it. And once you have built one, you keep on doing step 4, 5, 6, 4, 5, 6, and you keep on building as big. From 1 to 100 to 500, transit will keep on happening. And by the way, this is multi-cloud transit by default. You don't have to have the gateway only in AWS. You can choose this gateway to any other cloud type, whichever accounts you have here. Okay, any questions on transit? If not, then we will go to the next one.
A quick question on the controller, basically. So you have one set of controller, basically, in any of these clouds, and it then
No,
controls
it's just
everything?
one. Manage multi-clouds, multi-accounts.
Exactly. So
Sorry.
you choose whichever cloud you want to host
Yes.
in, and then it will manage everything that you've got.
So you could have one controller in one account on AWS in one region, and from that control any other AWS account in any other region, Google Cloud, Amazon, Azure. And so on.
Azure.
That's correct.
Wow.
Soon to
Yes.
come, Oracle. Now that
So
we've
you have
talked
to make a
about it.
strategic decision where to put it first.
It will, most likely you will put it where you are putting an operation tool anyway. Think about where you're putting your AD, where you're putting your, alt
Your Chef
stack,
Puppet,
Chef
your
Bucket.
Cloud Apps,
You are
And
anyway.
Share service.
Just for the sake of completeness, would it be complicated to migrate it over to some other account or region or cloud provider if needed?
No, we have a backup restore mechanism that you decide to change, you can
Launch it
you
and
back up,
recover.
all this configuration will back up into S3 bucket, so you can launch another one and restore
So let's
it.
say I want to migrate from AWS to Azure and move the controller over there, I can do that.
You just launch a new controller, dump the configuration.
Perfect.
Yeah.
Okay. Questions?
Well, it's just so you could have a backup in another cloud as long as you could copy the configuration files over.
That's true. You can have a multi-cloud controller, one as primary, other as backup.